Now we will look at applying these square root method steps to a little bit more complicated types of problems. The first thing that we want to do is to isolate the quadratic term. And once again, this means that we're going to look for the square. We want to look for that exponent of 2. We want to see what that exponent of 2 applies to. In the part A, we see that the square only applies to the x. So we want to get that 3 away from the x. In between the 3 and the x squared, there's multiplication. In order to undo multiplication, we will do division. So the first thing that you want to do is divide by 3. When we do that, we get x squared is equal to 27 divided by 3 is 9. And now we have isolated the quadratic term. And that was our step 1. Step 2 is to now take the square root of both sides. Now, x square root of x squared is x, and now we have solved for x. And we want to make sure that we do the plus and minus to capture both solutions. So plus and minus and the square root of 9 is 3. So we have gotten our 2 solutions and we have solved for x. For part B, we want to once again isolate the quadratic term. The square here applies to only the x, so we need to get rid of this positive 8. Now, in between the x squared term and that positive 8, we are doing addition. We want to do the opposite of that to get rid of the 8, so we will do subtraction. I will subtract 8 from both sides, and now I have isolated the x squared term. We have x squared is equal to negative 4. Now that we have isolated the quadratic term, we want to take the square root of both sides. Now the square root of x squared is x, so we have now solved for x. Now we need to simplify, and don't forget our plus and minus. Now we need to simplify the square root of negative 4. Now we talked about this in section 6.6. When we want to simplify a square root of a negative number, the first thing we do is separate the positive part from the negative part. So I'm going to rewrite this as positive 4 times the square root of negative 1. Now the square root of negative 1 we know is I, and the square root of 4 is 2. So we will simplify that as 2i. Now we have our 2 solutions, plus 2i and minus 2i. For part C, we actually will have to do 2 steps to get the x squared by itself. First thing we want to do is isolate the squared term. So we're going to look for what does that square applies to, and it applies only to the x in front of it. It does not apply to the 5, and it also does not apply to the negative 16. First thing we want to do is do any adding or subtracting. So because of the fact that that's a negative 16, and it's being subtracted from that x squared term, we will add 16 to both sides first. And then, because we have 5 times x squared, we will divide both sides by 5. So we get x squared is equal to 16 over 5. We have now isolated the x squared term. Now that we have the x squared term by itself, now we will take the square root of both sides, and we want to remember our plus and our minus. Square root of x squared is x, plus and minus, and let's go ahead and start to simplify this square root. We know that square roots are not simplified if there is a fraction underneath them. So we want to separate square root of the top, square root of the bottom. We want to simplify our radicals. The top is the square root of 16, and that is 4. And the square root of 5 would just be the square root of 5. So we separate, simplify, and now we want to rationalize. So in order to get rid of that radical in my denominator, I will multiply the top and the bottom by the square root of 5. I get x is equal to plus or minus, and let's simplify here. We get the square root, we get 4 times the square root of 5 on top, and on the bottom we have the square root of 25. So our final answer with everything simplified is plus or minus 4 times the square root of 5 on top, and we know the square root of 25 is 5. So we get our two solutions. X equals plus or minus 4 times the square root of 5 divided by 5. We want to make sure that we rationalize our fractions. Now for part D. This one is a little bit more interesting because we don't have an x squared, but we do have a square. And when we are solving using the square root method, we want to get the squared term by itself. So I want to look to see what the square applies to. And this time it happens to apply to everything there that's in the parentheses. So we have the quadratic term isolated already. There's nothing before it or after it. Everything that's being squared is on the side by itself. So we want to take the square root of both sides. And we have a group of 2. We have 2x minus 3 times 2x minus 3. If we can find a group of 2, circle it, cross it out, bring one of them out to the front. So 2x minus 3 equals, and we want to put in our plus or minus, and then the square root of 25 is 5. Now we want to solve for x. We want to be careful here. When I go to solve for x, we know that we want to add 3 to both sides. But the problem here is that that is not just a positive 5, and it is not considered just a negative 5. It's actually considered both plus and minus 5. If I try to add these together right now, I'm either going to get 8, but I can't say that's 8 because what about the minus 5? So I have to think about this. Because these are like terms and I know that I do want to combine them, we can combine 3 and 5, but I have this pesky plus or minus there that's keeping me from thinking about it as just one number. We actually have to think of it as 2 numbers. So we want to be careful here. When I go to solve for x, if I go to add this 3 to both sides, because these are like terms and I do want to combine them, but right now it's thought of as 2 different numbers, what I would like to do is actually to go ahead and separate the 2 separate values. So I'm going to say 2x minus 3, and I'm going to treat, in the first equation, I'm going to treat it as a positive 5. And then in the second equation, we're going to write the same thing, but on the other side now we're going to put a minus 5. That way, when I go to combine my like terms, when I add 3, that's not a positive 5 and a negative 5 anymore. Now that's just a positive 5. And I can actually do positive 5 plus 3. That gives me 2x equals 8, positive 8, and then divide by 2. So our first solution here, I get x is equal to a positive 4. Now on this side, in this equation, we treated it as a negative 5. That way when I go to actually solve for x, I can now actually combine these like terms without worrying about being 2 separate numbers. It's actually now just a minus 5. So now on this side we get 2x is equal to minus 2, and then divide by 2, we get our second solution, x is equal to minus 1. So when we are going to solve for x, and we have that plus or minus there, we want to check to see if these are like terms that we can actually combine. If I add the 3 to both sides, we can combine the 3 with the 5, but since it's considered a positive 5 and a negative 5 at the same time, we want to separate it 2 separate equations so that when we add the 3, we can do so without worrying about the plus and the minus being there. We have our 2 solutions now, x equals 4 and x equals minus 1. Alright, our last example for the square root method, part E here. We want to first use our square root method. We want to first isolate the squared term. So I want to know what is actually being squared. What does this square apply to? This problem here, I'm going to put a little star here. This one is a lot like one that's on your final exam. So the square actually applies to everything that's in the parentheses, but it does not apply to the 2, and it does not apply to that positive 10. So first thing I want to do is do any adding or subtracting. Because I'm adding a 10, then I will subtract a 10 from both sides first. And I still need to get rid of that 2, and I notice that the 2 is being multiplied times that parentheses, so I do need to divide both sides by 2 to eliminate the 2. Now I've isolated the quadratic term. Now that I've done that, I want to take the square root of both sides. 3a minus 5 squared, there's 2 of those, 2 of a kind. So when we find a group of 2, we circle it, cross it out, bring one of them out to the front. So that leaves me with a 3a minus 5 equals, now over here we want to include our plus and our minus. We want to simplify the square root of negative 49. We will separate that as a positive 49 and a negative 1. So the positive part from the negative part. The square root of 49 is 7. The square root of negative 1 is I. So now we have 3a minus 5 is equal to plus or minus 7i. Now the question is, do we need to separate this into 2 separate equations? And in this case, the answer is no. When I go to add 5 to both sides, we want to see, are these going to be actually like terms? Because of the fact that the I is there, the 7i, that is not going to be a like term to the 5. So I do not have to worry about separating them because I am not going to try to combine them anyways. So when I go to solve for a, here solve for my variable, I can just add 5 to both sides. Now what you want to be careful about here is that we don't actually combine these. We said these were not like terms. So when we actually go to solve for a, we are going to just put those side by side. My recommendation is to put the 5 in front of the plus and minus. 5 plus or minus 7i. So if they're not like terms, if you go to solve for the variable and you realize that we're going to add something and it's not a like term to what's on the other side, you do not actually have to do a physical separation of 2 separate equations. Now we have the 3a on one side and the 5 plus 7i on the other side. We still need to solve for a, so we will divide both sides by 3. Because we have an imaginary number, we want to write it in that a plus bi form. So I will keep the 5 over 3, the real part, separate from the imaginary part. So I'll write this as 2 separate fractions. 5 divided by 3 plus or minus the imaginary part, 7 over 3 times I.